Okay, I think this might be doing what it needs to do right now, so let's go ahead and sort this out. So we start out by downloading the threaded mount. This is a Fusion file, so I'm just going to download it by hitting that little arrow. And then I'm going to go through and work on the directions, but I have a couple screenshots here to help us out as we go through, just from doing this before. So I'm going to go into my Fusion, and I will go into a new, for me, I'm going to go into my admin, and then from there I will upload that file that I just downloaded off of Canvas. So that's going to upload, open the design. So they're starting us off with this, and we need to figure out how to, do what they want us to do. They're putting threads and things in there. So, oops, sorry, that's a different assignment, different class. Okay, so here we are, and it says, upload the design, we've done that. Expand the sketch folder and turn on the whole feature in Sketch. So I'm going to go here, I'm going to bring this down here, and I'm going to go to the whole feature and turn the eyeballs on. And it says select the 4 points on the corner of the hole feature. Set the hole type to counter bore, diameter 7.5 millimeters, the tip angle to 118 degrees, the counter bore depth to 1.5 millimeters, and the counter bore diameter to 10 millimeters. Extends to all. So this whole thing that they have here is a little different physically, which is why I have that screenshot on Canvas. So let's see if we can sort it out. So we're going to do 4 drill holes, and we're going to do counter bore. So that's kind of the important part right now, is that we go here and we go to hole. We're going to put one here, one here, one here, and one here. So then I'm going to look over at the rules of what I have and what needs to be done. So it says we need counter bore. So if I go into this top one here, hole type, simple counter bore, countersink. So let's click it over to counter bore. And then it says the diameter is 7.5 millimeters, but then the counter bore diameter is 10. So let's do that. So we have this diameter is going to be 7.5. Oops, I didn't mean to hit that. Sorry, double click. Okay, so 7.5. This diameter here is 10. And then it says the depth here was, I want to say 2.5. Let me just make sure. Yep, 2.5 and 118 for our degrees. So let's do 2.5. Look, this is already 118. So then the only thing I have to worry about is the height of the actual hole. Let's see if they give us one. It says extends all. So that means we're going to go through this part here, drop down. Does it give us an all option? No. There's got to be another place for us to, here. So under extends, we're going to go to all. Okay, so that is our drill hole there. Anything else weird it has us do? No, that's it. So then it says make sure the command is going in the correct direction, and then click OK. So that part is good. So now it says enable the shell command to hollow out the underside of the model. Select the back flat face of the mount as the face to the shell. So we're going to go ahead and hollow it out, 2.5 millimeters. So I'm going to go to this thing called shell, click here, bring that in. Like, you can kind of mess with this here and it's going to get mad at you. So just do 2.5 and then it'll be okay. It's because it wants to do like more or less and then it can't. How's that look? Yeah, that looks like what they have. Okay, next it says drag the marker to the end of the timeline to include the feature in the model. So that means we're going to go here and we're going to go down here and pull this forward. Now it says turn on the sketch web feature, enable the web command to create the supports in the inside model. Select the 4 sketch lines as the curves set to the thickness of symmetrical, depth to next, and the thickness to 2.5 millimeters. So we're going to go in here, we're going to turn on the web feature. We're going to go to web. We're going to kind of roll this so we can see what we're doing. We're picking all of this. I feel like the circle should be picked too, but I don't know if that's the case. And then we're going to do symmetric. And we're going to say to next. And the thickness is 2.5. So to next. 2.5. Okay. Is that what it looks like, or did they not do the circle? Let's see. I just don't know if the circle should be included. It says the 4 sketch lines, so that does not include the circle. So let me take that circle out. So I'm going back up here, and I'm just clicking on that circle if I can get it. Can I get rid of it, or do I have to go out? Let me just do this. 1. Oh my gosh. It's got issues, guys. My computer's frying itself. Okay, let me X out of that. Cancel it because it's lost its mind. Okay, so we turned on the web. Sorry. I'm going to go to web. Put this line, this line, this line, this line. We're going to make it 2.5. Make sure this is symmetrical. Make sure this is to next. And hit OK. That's what you have for that. Okay, next it says apply a chamfer to the end of the shaft protruding from the model. Select circular edge and then make it equal distance 3 millimeters. So here we're going to go ahead and do a chamfer on this side. And here, chamfer, do this circle, go in 3 millimeters, equal distance, and hit OK. Next, it says use the thread command to create the threading on the shaft. Activate the thread command and select that face. Check the model, and for full length boxes, we want isometric, ISO, and then metric profile. The size is 39.0 millimeters. The designation is M39 times 4. The class is 6G. Okay, so let's see if we can sort all this out. This is the thing. When you do threading, is threading here? Yeah. Picking this. So then it has all those things. Isometric profile. I'm going to add modeled. If you don't click modeled, you don't actually get to see what's going on. 39 millimeters, M39 times 4, 6G, right-handed. I think that's everything. Probably the last time I did a thread. Yep. So let's look at it. Let's hit OK. And it didn't do anything. That's really annoying. Oh, it did. It threaded the inside and not the outside. Maybe that's the way it's supposed to be, but I don't think so. Let me double check. So it's supposed to be threaded. We go all the way to the very top. Yeah, it's supposed to be threaded there. Let me go back to my threading. And then, is there a way to Oh, now it's fine. Okay, so it was a glitch with the computer program. No. It's lost its mind. Good to know. I'm just moving this around to figure out what's going on. Obviously that's not what I want. So I did model full length. And I'm going to hit OK. Okay, that time it worked. I don't know, that was a weird, I think that was something to do with Fusion and had nothing to do with us. Okay, so once you have this, it says to make sure, set the material in your body to physical material. Set it to steel alloy, and then we can check it. So we're going to go to steel alloy here, so we're going to modify physical appearance. We're going to say steel. What are the chances I have that here already? Probably pretty high. Okay, metal, and then go down to steel. Steel non-alloy, steel mild, steel alloy. Drag it on.